Hi, good afternoon. In this video, the students will deliver about one of the case study titled Formation and Functional Nanofibrous Electrospun Polyurethane Contain Grapes for Wood Healing. In this PPT, the students will discuss about abstract of the study, materials and methodology, resultant discussion, and finally conclusion.
Firstly, abstract. Electrospinning is an emerging tool and promising method to fabricate polymer nanofibers. The aim of this work was to fabricate electrospun polyurethane mats reinforced with grapes for wound dressing. It was confirmed that fabricated novel composite scaffolds having better psychochemical properties suitable for wound dressing applications. Wound dressings plays an important role in managing certain types of open wounds, including traumatic, thermal, and chronic wounds. The materials utilized in making wound dressing were biological synthetic. The biological wound dressing which is commonly used in clinics are alloskin and pigskin, but they possess some drawbacks like limited supplies, high antigenicity, poor antiseptic, and risk of cross-contaminations. Electrospinning. An ideal dressing must provide moist environment and allow gases exchange at the wound interface to fight against microorganisms and also remove excess education for quick healing. Wound dressing fabricated using electrospinning technique is potentially offered many advantages over conventional process. Electrospinning is a versatile and cost-effective technique as it involves applying high voltage to polymer melts, which is drawn into nanofibers at the collector end. The electrospin membrane helps in cell attachment and polyliferation, favoring the wound healing process.
Materials used: polyurethane. Polyurethane is one of the commonly used polymers in making dressing material in form of foams, membranes, and films for wound healing applications. Materials used: grafts. In this works, the nanocomposites is derived using the additive called grafts. The fresh grapes extract consist of 70 to 80% of water and many organic and inorganic compounds such as sugar, organic acids, and small amount phenolic nitrogenous compounds with methyl oxide and parasites, 4-vinophenol and minerals, and plastic substance. Few studies have been reported antioxidants, anti-cancer, antimicrobial, and anti-inflammation activities of the grapes, which reported phenolic constituent of grapes as a putative candidate. Preparation of solutions.
Here the PU at 9 WT percentage was prepared by dissolving 0.405 gram of PU in a 4.5 ml of DMF and stirring for 24 hours at room temperature. Subsequently, grapes at 9 percentage was used to fabricate the composite nanofibers and was prepared by dissolving 0.405 gram of grapes extract in a 4.5 ml of DMF solution and stirring for 2 hours maximum. And then finally the solution of PU grapes was prepared by mixing the PU and grapes a homogeneous solution in the ratio of 8:1 and stirring for 2 hours maximum. PU and composite solution nanofibers were obtained using an electrospinning technique.
And their characterizations like scanning microscopy and their attempted total reflections and infrared to spectroscopy analysis and the contact angle measurement and their thermogravity analysis and atomic force of microscopy. Some investigation. It was found that PU grapes nanofibers exhibited a decrease in fiber diameter compared to the pristine PU, and their diameter of the PU membrane was observed to 730 nm, while PU grapes and nanofibers showed that the fiber diameter 890 mm, and the smaller diameter will be favorable for fibroblast cell addition and proliferation.
FTIR analysis. The key peaks in PU were NH, CH and CO groups. Compared to pure PU, there were no additional peaks observed in PU graphs, but both peaks were observed in NH peak due to the formation of hydrogen bond. The strong increase in the intensity of the peak at 3322 cm and 3398 cm may be due to the reaction of graph extracts OH, CH and groups which the molecules of precedent PU. Here, the PU compared to PL graph has lower intensity, which indicates PU has smoother surface.
PU contains grapes.
PU contains, which indicates PU contains grapes. Contact angle measurement. The water contact angle of PU was found to be 1000 plus or minus 1, indicating the hydrophobic nature, while the PU grapes nanofibers showed a contact angle of 86 plus or minus 2, indicating its hydrophilic nature. The improved wettability will be favorable for fibrillous cells addition and proliferation. Thermal stability. From TGA curves, it was observed that the PU membrane showed an initial onset degradation temperature at 276 Celsius, and in the case of electrospin PU graph nanofibers, the initial degradation temperature was increased to 289 degrees Celsius, indicating the increased thermal behavior of the electrospun nanocomposites. In TGA curves, the PU compared to PU, the PU graphs have larger intensity. Surface roughness. The calculated surface roughness for the PU membrane was found to be 313 Newton meter, while the electrospun PU graphs nanocomposites showed a surface roughness of 469 Newton meter respectively. The incorporation of graph improved the surface roughness of PU membrane. The improved surface roughness will be suitable for fibrillous cells addition and proliferation. Compared to in PU, the surface will be smoother. In PU graph, it has a rough surface.
Finally, I will conclude my session. Hence, the developed nanocomposites comprising PU containing grapes showed better physiochemical properties like smaller fiber diameter, wettability, and a rougher surface, which may be suitable for the interesting applications. Thank you.